Hi all. So in this chapter 19, we're going to actually talk about the second part of the cardiovascular systems, which is blood vessels, right? So we have spoken already about heart, which was the first part of the cardiovascular system. So there are two stuffs. One is a cardiac part, and one is the vessels, how is being, or the vascular part. So that's the second part we're talking about is blood vessels. So the cardiovascular system is a combination of heart and the vessels. All right. So first we'll talk about the vessels, the three layers of blood vessels. Then vasoconstriction, vasodilation, arteries, the types, capillary bed, veins, the types, structure functions, as well as we'll also talk about structure function of arteries, and finally anastomosis. Okay. So what are blood vessels? First we'll talk about structure and function of blood vessels itself. So what are blood vessels? These are the system which actually begins and ends at heart. So what does it do? It circulates blood, first of all. Connected with also lymphatic system, like you see here. Lymphatic system also actually helps circulate a fluid that is called a lymphatic fluid, or lymph basically. But that's another system, although, and lymph is produced from blood, but we'll talk about that later. So in general, blood vessels carry blood. That's it. What are the types? Three: arteries, capillaries, and veins. Okay. So number one is arteries, number two capillaries, and veins at the third type. What does arteries do? They carry the blood away from the heart. Away from the heart. They carry oxygenated blood. So when heart have received the oxygenated blood from lungs, that is delivered by artery. The major first artery, you do know this, that is connected directly to the heart is the aorta. Then aorta branches into several branches to deliver that oxygenated blood, right? So arteries carry oxygenated blood. The only exception is the pulmonary circulation. You remember the pulmonary circulation in heart? If you don't, then go back and check that the only exception to carrying oxygenated blood is a pulmonary artery, okay, which is directly connected to heart and lungs. And then comes the umbilical vessels of fetus, because umbilical vessels actually carry some can carry deoxygenated blood. Now the second one is capillaries, which serves the contacts the tissue cells, right? So here is our heart. Artery carries the blood away from the heart. These are the arteries. But there are veins that carry blood away from the heart, right? That actually, sorry, the opposite way. That carries blood to the heart, okay? There is some connection in the between. That's called as the capillaries, okay? So veins carry to the heart, and what kind of blood they carry? They carry deoxygenated blood, okay? But in between we have this component called as the capillaries. Exactly, you see here, blood, vein and artery carrying blood away from the heart, veins carrying to the heart. In between we have these capillaries, which is kind of exchange vessels. And the reason we have this, because they serve the cellular needs, they serve the cells, because artery and vessels cannot really reach every single cell of our body, and that job is done by capillary. They are tiny, super tiny. All right. The only exception for veins, like artery, veins carry deoxygenated blood, but except for pulmonary circulation and umbilical vessels of fetus. In both cases, they can carry oxygenated blood as well. If you don't remember what pulmonary circulation is, please refer to heart, chapter 18. Structure of the blood vessels wall. So blood vessels wall is typically very important for maintaining our blood pressure. Okay, so all vessel have a lumen. What is this lumen? Lumen is basically the the hollow. This whole thing, this hollow part is called as a lumen. Okay, the gap, the central blood containing space that is surrounded by several kinds of walls. For example, the innermost wall is called the intima, tunica intima, right? It is made up of, it is intimate because it is intimately in connection with the blood itself. It is made up of simple squamous cell. It is also called as endothelium in smaller ones specifically, because it is made up of endothelial cells. Like for example in capillary. But anyway, so tunica intima in arteries or veins, they are made up of single epithelium cells, just one single layer. The next one is called tunica media. Okay, now this layer can be thick in especially in case of arteries, and this is made up of smooth muscle. So you should know what the layers and what kind of cells they are made up with. Like this one is made of squamous epithelium, this is smooth muscle. Okay, this is the bulk, like I said, this is the bulkiest layer. It is the one that is responsible for maintaining blood pressure, blood flow, right? And they are heavily regulated by sympathetic nerve fibers, so they can undergo vasoconstriction and vasodilation. What does this mean? Vasoconstriction simply means it is the narrowing of the lumen. When the vessels actually constrict, that is called a vasoconstriction. And vasodilation is when the lumen actually increases, that is called as the vasodilation. All right, so if we have too much of vasoconstriction, if the vessels decrease too much, like you can imagine it is compressing the vessel, in that case the pressure will increase. And if it's not, if it's dilating, then the pressure will decrease the blood vessel, because basically it will, under vasodilation, it will be easy for the blood to flow. Then third is tunica externa. This is the outermost layer. It is another name of this is called tunica adventitia. It is mainly made up of collagen fibers. Okay, this is the external layer, so its main function is to protect everything that is inside, and it is also infiltrated with nerve fibers as well. All right, so that's artery and vein. We see these three layers in there: intima, media, externa. And in capillaries we don't have these fancy layers. We only have a layer of endothelium. Okay, like one layer of cell, endothelium surrounded by a basement membrane. So just one layer of cell. They are very thin and tiny. So let's first talk about arteries. First and foremost, again I'm repeatedly telling you, you have to remember this thing, that arteries only carry oxygen rich blood from the heart to the body tissues of our body. So arteries are three kinds. Firstly, elastic artery. These, like this one, these are the thickest one, thick walled. Why? Because they have the thickest of tunica media. And tunica media is what? Tunica media is made up of smooth muscle. So they have a lot of muscle in them. It's a substantial amount of smooth muscle is there. Okay, but they cannot constrict that much. One of the major example is aorta and its major branches. These are all majorly conducting arteries. Basically their job is to conduct the blood, transport the blood very fast from the heart. That's why they cannot afford to constrict that much, right? And they don't have much of resistance within, like the blood cannot face much resistance. If they do, for some reason, that's fatal for us. Okay, and they are actually the pressure reservoirs. Okay, because they have to maintain a continuous blood flow. Even the heart, whenever the heart is beating, they still have to maintain that blood flow. So maintaining of the flow, the pressure is quite important. So they cannot afford to have much obstruction, elastic arteries like aorta. So therefore, they don't have much of vasoconstriction in them. The second type is called muscular artery. So the muscular artery is the distributing artery. So aorta is the main one, right? And then the main dividing ones from aorta will still be the conducting arteries or elastic arteries. Now we're talking about, so these first degree will be the elastic ones. Now when things are branching off from the first degree elastic, these guys will be the muscular one. Okay, these are called the distributing arteries, the second degree, and their diameter can range from a pinky finger size, like you can imagine, to a pencil size. So they are not very thick as aorta is. Most arteries are like that. Okay, account for most of the named arteries rather, and they have also a thick tunica media with more smooth muscles, but they don't have much of elastic tissue, because elastic tissue is more present in the elastic arteries. They still have a thick media, but less of elastic tissue in them. Okay, but these guys actually can undergo vasoconstriction. They don't have to maintain that pressure of flow as much as the aorta or the immediate divisions will have to do. The third category is arteriole. So when the second degree also divides into tinier, that is called as the third degree, which are the arteriole. Okay, so the third degree here. So this is the third degree, smallest of all the arteries. Larger arteriole, generally arterioles might not have 3 tunics, but the larger ones can have. Okay, so smaller arterioles are mainly just endothelial cells, right? So again, aorta, or the bigger one, first degree, which are the elastic one, and their main branches. One that branches off from there, that will be the second degree, which will be the muscular one. And even branching off from that is our arterioles. Okay, these are the smaller ones, third degree arterioles. So elastic muscular arterioles. These actually leads to capillary bed. What is capillary bed? We'll come talk about that in a second. These are called resistance arteries because they are so tiny and they change in keep changing the diameter, so they kind of resist, sometimes can resist the blood flow within them because the diameter is pretty thin. So these arterioles actually leads to capillary. So if this is an artery, second degree, and then this is the third degree arteriole. So again, this is the first degree, second degree, which is, and then this probably is third degree, and that is leading to this capillary. What is capillary? These are fine branching blood vessels that kind of networks between arterioles and venules. Arteriole, venules is the same thing to arteriole, but for veins. We'll talk about that in a minute. But these capillaries are very small microscopic vessels. Sometimes it can be so thin that it can only pass 1 RBC. So it's like micrometer thing, right? They supply almost to every cell. The reason they are so thin, because like I said, arteries and veins cannot reach everywhere, but capillaries are so thin that they can like reach anywhere. So they actually supply blood to every single cell. Certain exceptions are cornea, lens, cartilage, epithelia. Okay, what do? The exchange of gas, nutrient, waste, hormones, anything that blood will do actually is also will be done by the capillaries, because again their job is to reach the cell, so they have to function accordingly. If these capillaries are continuous, means they're abundant in skin, muscle, lungs, and central nervous system, or they can form blood-brain barrier, or they can be fenestrated, means little bit of gaps in between. So if like that, and then they will have some gaps in between. Okay, this actually allows permeability, and therefore where it will be required, anything that is doing some form of filtration, absorption, like that in kidneys, intestine. Why? Because things have to pass through them, right? Or that's why fenestrated. Otherwise it will be continuous, like in skin, central nervous system. In central nervous system you do not want any gap, otherwise blood will mix into brain. We don't want that. That's why it forms the blood brain barrier. And finally sinusoidal, which have very fewer tight junctions, fenestrated with large clefts. It's found in larger lumens and only found in liver, bone marrow, spleen, all this area. Alright, so that's how a capillary bed will look like. So this is the capillary bed. Now this capillary bed actually leads also into venule. Like arteriole, it also has venule. So next blood vessel is obviously therefore venule. What is venule? The next blood vessel is vein. And veins, obviously like artery, carries blood from heart. This carries towards the heart. So it carries the deoxygenated blood, right? Arteries carry oxygenated blood, veins carry deoxygenated blood. That's why I have written it in blue. And same thing for the artery, it was written in red. So from capillary bed, now capillary bed unites and becomes venules, like I showed you here. Sorry. These capillary beds unite and they become these venules. Okay, so venules are the tiniest veins. Smallest venule can be just only made up of endothelial. They're very, very porous, allows fluid to go through. Larger venules might have tunica media and some tunica externa also. Veins have all tunics as such, and there are no types as such with veins. All right, there are no as such types like artery. So they will have tunica intima, media, and externa, but they have thinner walls. Okay, so tunica media is thin, externa is thick because it is made up of collagen and elastic fibers. Best example is vena cava. Okay, and they have larger lumen. Let's quickly go back to the first picture. Like here you can see they do have, but their tunica media is pretty thin. Okay, tunica externa rather is a little bit thicker. So that's the difference. Here the tunica media, the tunica intima is pretty much the same, but in arteries the media is thicker. Here the media is thinner in veins. In arteries the externa is thinner, but in veins the externa is thicker, right? That is made up of collagen fibers. Why it is like that? Because arteries have that thick muscle, because they are the one who is responsible for maintaining the blood pressure, so they have to constrict or dilate to continuously go under that process. But veins don't have that pressure, because veins is simply carrying the deoxygenated blood back to the heart. So if it reaches a little bit later, that's fine too, so it doesn't really matter. It kind of passively blood flow happens through vein. Okay, so therefore, but since this is the blood flow happens slowly, passively, they are good storage vessels. Okay, they're called as blood reservoirs or capacitance vessels, because they contain 65% of the blood supply. They store the blood. So if we split up in terms of blood storage, we will see that the systemic veins and venules have the most amount of blood present in these veins and venules. Arteries will have a 60% approximately. Arteries will have approximately a 15%. Heart itself will store 8%, capillaries 5%. The pulmonary vessels will store like the approximately 12%, which is the connecting to the lungs, these pulmonary vessels. So blood pressure therefore in veins is naturally lower than, like I said, it's lower in veins because it passively flowing the blood away from the organs, right? But two important things, other structures that veins have, firstly is venous valves. It has valve, it prevents backflow so that the deoxygenated blood doesn't go back to that organ again. Or venous sinuses, which is the flattened veins with extremely thin walls only composed of endothelium. Right, we see this in coronary sinus of heart. In heart actually we see that. It's a comparison of blood vessels anatomy. So you can see in arteries, first of all, we have all the tunics. In elastic arteries, we have a higher amount of smooth muscles. But since this is elastic artery, we also have good amount of elastic tissue. Exactly the opposite in muscular. We have a really high amount of muscle, but low amount of elastic. In arterioles, everything is lower, but still slightly more smooth muscle. If you do a direct comparison to veins, the bigger vein will have all the tunics, but still it will have the tunica intima, the muscles, the elastics. This will be much lower, but what is highest is this one, which is the collagenous tissue, which is seen in the externa, tunica externa. Okay, so that is highest in veins. Let me write that down one more time. We're talking about the externa here. Externa is pretty highest or pretty big in the veins. In venules though, we don't see any elastic. We simply see some smooth muscles and the fibrous connective tissue outside. In capillaries, we see none of these. We only see some endothelium tissue, just one layer of cell. Now, anastosomes, what is this? These are interconnection between blood vessels. So blood vessels actually can kind of sometimes form an alternative pathway. For example, arterial anastosomes, okay, provide an alternative pathway, collateral channels to ensure a continuous blood flow. We commonly see this in joint, abdominal organ, brain, heart, but not in retina. That is eye. Venous anastosomes, so abundant that occluded veins really basically block the blood flow. And the most important one is arteriovenous anastosomes. This is a shunt between the arterioles and the venules. Okay, this is the most important one because they form a shunt, a bypass way, okay, between the arterioles and venules. So this is the most important interconnection. Question for you: An increasing lumen diameter is termed as, so we learned two terms, vasodilation and constriction. So if it's increasing, that means lumen is basically increasing in diameter, so that is called as vasodilation, and occurs when the smooth muscle is obviously relaxing, the tunica media is relaxing. When we're talking about smooth muscle, that means we are talking about tunica media. Of the following blood vessels, which is the most critical for regulating blood pressure? So we discussed about this here previously. The first of all, I'm not going to tell you this answer, I'm just going to give you a hint. So arteries maintain most of the blood pressure because they have to, because we have to ensure that our organs or organelles have enough amount of oxygen. So, and that is done, so therefore and that oxygen is delivered through artery, therefore arteries have to maintain that blood pressure. So whichever thing is significant in the artery, that's your answer, right? The third one, which vessels are responsible for exchange of gases and nutrients in the tissues? Which will be capillaries, because tissues and cells are mostly reached by capillaries, that's why they are so small, right? So work on number 2 on yourself. Next thing, we'll talk about blood flow, blood pressure, resistance, how blood pressure differs in artery, capillaries and veins, factors that can affect blood pressure, and hypertension. But we're not going to cover everything now. We're going to talk about the first part mostly, blood flow, pressure and resistance. What is blood flow? Blood flow is the volume of blood that is simply flowing through the vessels, organs, or the circulation. And it is measured in how much blood is flowing in a ml in per minute. So ml per minute, and blood is liquid, so ml per minute. It is equivalent to cardiac output for the entire vascular system. Overall, this is kind of constant, but it can change also. Based on, suppose you're running, walking, doing some intensive activity, your blood flow might increase. Or if not, you are sleeping, then blood flow might decrease. Okay. Blood pressure is the force exerted per unit area on blood vessels. So if this is your blood vessels, how much pressure is exerted in 1 unit area, that is your blood pressure, all right, expressed in mmHg. We have learned about this a little bit, right? This is measured as a systemic arterial blood pressure, means because arteries have the most blood pressure, and if we measure this as close as possible to the heart, in that case we will get the best possible measurement, right? Because we want to measure something that, I mean, blood pressure is a critical component, so we don't want to know what happens when it is at low, because if blood pressure is low, that's fine, but if blood pressure is too high, then what will happen? Even the blood vessels will not be able to accommodate it. So therefore it is critical to measure blood pressure when it is at its peak, so that making sure that the blood vessels are staying intact and our systems are staying intact, right? So therefore blood pressure is actually measured in the systemic arteries that is close to heart, all right? And pressure gradient provides the driving force that keep the blood flowing from high to low pressure. So we cannot have too much pressure at one area, so it has to get away. And what is resistance? It's the opposition to the flow. If for some reason when blood flowing it is going through some resistance, then that is called as the peripheral resistance. Periphery of what? Of the blood vessels. I'm going to stop here for the first lecture, and then we'll actually repeat this little bit in my next lecture, and then we'll start from resistance. All right, see you then.